Hey everyone. Um, Last panel of the track, last panel of the day, and the last day. We're talking ZK, so everybody who's still in this room, you are troopers. Appreciate it. So we're gonna kick it off with just a quick round of intros. So we could start with you, Sven.
Cool. Yeah, glad to be here. My name is Sven. I'm one of the co-founders of Light Protocol. Light Protocol is a ZK scaling protocol on Solana, and we have an account and token standard that you can use to reduce the cost of data storage if you use Solana.
Hello. Yeah. Hi everyone. I'm Yannik, co-founder and CEO at Arjoon, and with Arjoon we are bringing encrypted computing on chain. So Arjoon itself is an encrypted computing network that allows for confidential and encrypted on-chain operations for any type of computation to be executed, and that ranges from confidential DeFi applications up towards even confidential machine learning, training, and inference.
So this is the ZK Endgame panel, but there's some irony here where, Light Protocol, it doesn't really use the ZK bit, it more uses the succinct part of it. And then with Archeum, you told me that you've actually moved away from ZK. So for the privacy element, do you mind, Yannick, delving into that a little bit more?
Sure, yeah. So basically, our origin story is that initially with Archeum, when we started 3.5 years ago, we were using zero-knowledge proofs for on-chain privacy. And at that point, it was more focused on purely transactional on-chain privacy in order to add privacy to peer-to-peer transactions on-chain. And for these kinds of privacy-related applications, zero-knowledge proofs are quite suitable, because at the end of the day, what a zero-knowledge proof allows you to do is to keep a secret to yourself and then run and prove some computation over that secret and only submit the zero-knowledge proof while keeping that secret to yourself. And so in these kinds of operations where you are the custodian of these secrets and you can keep them to yourselves, ZK is a great technology for these kinds of privacy-related applications. Now, what we realized when building these kinds of applications is that we actually needed computations over all participants' secrets without them having to share them with anyone, but people couldn't just keep the secrets to themselves and run those computations locally. So they needed a collaborative computation protocol, essentially. We call that encrypted shared state computation. So all of the user state gets encrypted, and then there's some computation taking place over all of this encrypted state. And so that's why we then decided to move away from pure ZK. ZK, of course, is always part of most cryptographic applications and protocols. ZK really is a primitive that plays different roles within those architectures. But in general, the core technology that is backing this kind of encrypted computing, where you're running computations as a third party, basically as a network, over data that you don't see, in our case is secure multi-party computation with semi-homomorphic encryption. And these kinds of confidential computing technologies, as you would normally classify them, allow for these kinds of privacy-related applications. So in my mind, it's really, I guess the union of both purely ZK applications and then encrypted shared state applications that enable the level of privacy that we need, not just within Web3, but in the entire internet.
And with your MPCs and homomorphic encryption, are these run on TEEs, trusted execution environments?
So basically, the whole point behind the kind of technology that we are building is that you don't have to trust anyone, right? And so we don't want to introduce any trusted players into these kinds of architectures. And so the way that we've designed our protocols from the ground up is to operate in the lowest possible trust assumption. So I can get a bit more technical, slightly more technical, and in general, what MPC does, MPC, secure multi-party computation, allows a set of participants to jointly compute a function over private inputs that remain private, right? Whereas zero-knowledge proof allows one party to prove something around private inputs, MPC really allows a set of participants to jointly compute such a function while keeping their individual inputs private. And so the way Archeum functions is that Archeum itself is this network that runs those secure multi-party computations. And the private inputs into those computations are the user data. Now, the user doesn't give any node within Archium the data. Instead, what the user does is they encrypt it to a public key to which no private key exists. And then each participant within Archium, each node, can take that ciphertext and transform it locally into a so-called secret share, which is then a single secret, a single private input that gets put into this computation, and then the network collectively can run a computation. And as output of those computations, of course, they can produce zero-knowledge proofs, for example, and then verify those zero-knowledge proofs on-chain. But in general, they just run those computations, and the output then can, again, land back on-chain. And so Archium gets computational tasks from some on-chain smart contract, executes it, and settles it back. And crucially, what's important to realize, trust model-wise, while comparing privacy-related applications and normal distributed ledgers, is that on a distributed ledger with practical Byzantine fault tolerance, we are operating in an honest majority setting. And even if some fatal flaw occurs where there's some dishonest majority controlling the entire network, we can sort of fork the network and recover. With privacy-related applications, that's not really the case, because what you want to protect can only has to be stolen once, I guess, right? And so the trust models need to reflect that. And in the case of Archium, the trust model that we've developed for our cryptographic protocols is the so-called dishonest majority trust model, which means that as long as there's one arbitrary single honest participant within any given computation, all of the secrets that are being input into the computation can remain safe and private. And so that's why we don't need to actually introduce trust by running our computations on trusted hardware, but instead we can have this purely cryptographic solution.
Okay, thanks for that technical explanation. Okay, MPC, homomorphic encryption, no ZK, and like Light Protocol, no real ZK either. It's more useful using the succinctness of it. And Archium has no shared state, but Light Protocol is all about the state. It's about compressing the state. And I think when Light Protocol first came out with this idea, there were some comparisons between compressing the state and what rollups do, like maybe a ZK rollup compresses state. Do you think this is a fair comparison, a good comparison, or is it insulting?
Yeah, cool. So for context here, I think roughly a year ago, we, together with Helios Labs, which is one of the leading RPC providers on Solana, we announced ZK compression, and it kind of had this discussion on crypto Twitter where some folks were comparing this to ZK rollups. And the main difference, and there's some similarities, but there's a main difference. And the big difference is that with rollups, as you see them often on Ethereum, execution happens off-chain. So the actual state transition function of a specific app or let's say a token transfer happens off-chain. And then many transfers are being batched together and then settled on-chain with a proof. And then some data is published on-chain as well. The data publishing aspect is very similar on a technological level. However, with ZK compression, which is what we're building, the state transition function is actually very minimal, what we're proving in off-chain. It's actually just Merkle-proof inclusions that we batch together. The transfer logic, the sum checks, the ownership checks that you would associate with, for instance, a token standard is happening on Solana. It's being executed on Solana. And so there's this fundamental difference where we are very much about, you're still executing on Solana. It's the same safety guarantees, the same composability that you have with regular Solana accounts. But we reduce the cost of these accounts that you create on Solana, right? So for context, for those who are not super familiar with programming on Solana, whenever you create a token or you create you want to store some data on Solana, you have to pay something that's called rent. And it's actually kind of like a bond that you have to, which is a little bit of Lamports that you have to put into an account. and then validators know that they need to hold on to the state. Now with Solana, that rent is pretty expensive. So if you have a single token account, for instance, like if I want to send you a USDC, 1 USDC, I have to pay 0.002 Sol in rent for this. So I would pay roughly 20 cents in rent. And so this gets pretty prohibitive if you have use cases that require you having a lot of tokens or having a lot of users, millions of users maybe. So if you want to create a lot of state on Solana, you have this problem right now. And it's actually funny because L2s like Base, for instance, they don't have this problem. So in that sense, Base is actually cheaper than sort of the vanilla on-chain accounts. If you want to, do an airdrop on Base, or you want to create a lot of token accounts on Base, or have a lot of users on Base. Now with ZK compression, we reduce the cost of data storage on Solana, and so far that it's on par with data storage on Base, even though it's actually happening on Solana, which has a validator set of thousands of nodes and it's decentralized and is a layer 1 blockchain, right? So you have, in my opinion, stronger security guarantees than you have on an L2 like Base. So I guess that's the main differences, and then obviously similarities in that you're posting some data on chain. We can go into how it works maybe later as well.
Oh yeah, that's great. Yeah, so definitely insulting to make that analogy between the two. More composability, better security model, and it's just compressing the state. There's no off-chain execution anywhere, so it still relies on the L1. Okay. Well, this is a ZK panel, and it's about the Endgame, so I want to ask you all, and I'm going to use the term here, ZK, a little bit more holistically to even conclude succinctness. So, in the Endgame, when maybe that's 10 years, 15 years from now, who knows, how are we going to know that ZK has succeeded, right? What are the metrics, the KPIs that we're looking for? How do we know that this thing is real? And then, on Yannik, on your end, you might even say that maybe ZK is not even necessary based on the design of your thing. But Sven, let's start with you.
Sure. Yeah. Happy to. And I actually have some very firm beliefs here. And so, I'll give some more context to start with, because actually one fun fact is that back in the day, I think roughly 3.5 years ago, both of our teams started out with privacy, purely privacy. So what you'd call ZK, right? Like the true ZK, where you prove some hidden knowledge, for instance, over funds or a balance change, right? And over time, we both teams kind of shifted their go-to-market, shifted their product offering. And I think one of the key reasons was that ZK just had this market problem where the timing was not right for ZK tech to actually help be meaningfully impactful for a lot of users. And I think that's changing a little bit. But what I mean by that specifically is ZK itself is technology, and I think it's great. And I think, as you mentioned with your question about the Endgame, I think the main metric will be how many users on Earth are going to use ZK as a technology. And then whether they know that they use ZK is a totally different question. And in my opinion, most people will not know that they use ZK under the hood. But so the question is really like, how do you bridge the gap from now we have cool ZK tech, or other mechanisms to have a private state like MPC, FHE, or TEs. How do you go from there to actually getting a meaningful adoption, like billions of users, right? And so the way that I think about this is that so far, the main use case for ZK that was actually having product market fit was something that you see with, for instance, Zcash, where you have cold storage that is state that is at rest, right? So let's say you have token accounts or token balance that is at rest, so it's in your cold storage, and having that be encrypted. And then whenever you want to interact with Zcash right now, for instance, oftentimes those are semi-public transfers. So you actually go out of your cold storage to then send Zcash to another user, right? And I think that's really a strong PMF for ZK already. And so the question is really like, how do you distribute that to billions of users? Because the truth is, in DeFi so far, the market of people that cared about having private state at rest was very low, right? Especially in a trust minimized environment, right? Oftentimes you just go through a centralized exchange and it's fine. You kind of have like pseudo privacy. So I think it's going to be the shift in the market realizing that privacy at rest is actually important. I think more meaningful adoption from institutional players and larger firms will really play into this, where you now have maybe high net worth individuals who are used to a more obfuscated financial system, or businesses kind of really demand this as sort of like a P0, P1 feature, right? Private state at rest in the bank accounts. So I think that's, and then proliferating that model with stablecoin adoption, cross-border payments, and other types of payments, I think is one way that ZK can go to like 1 billion plus users, and which I think is the ultimate metric that we should strive for. Because ultimately, what I believe is that zero knowledge tech is I think Zuko from Zcash called it recently machinery for freedom, which is like, it's super important for humanity to have, and for real sovereignty in the end, to have private state, private funds, private money at rest. I think that's really important. And I see we do have some time, so I'll dive a little bit deeper here. To continue this thought, I think it really depends on, like, we need more founders who actually use ZK tech to solve real problems and build apps that utilize ZK under hood. And I think, as I mentioned, for money on chain, that is the privacy address. I think Zcash is a great example of this. And it's much less so in my opinion, the public shared state. So DeFi, for instance, there's a lot of benefits on having transparency. So I guess the end state that I envision for myself in my own mind is we will have a lot of shared state that is public on chain, like chains like Solana, or maybe even L2s like Base. And then the actual user state at rest in wallets, for instance, or cold storage is going to be encrypted by default. And then you have all these nice properties, edge compute, self-verifiability for these wallets of stateful blockchains, etc. And so that's what we took and looked at for our design for Light Protocol as well, because funnily enough, the product offering that we have that we see actually solving a problem for real users right now is state compression with reducing the cost of data storage, right? It's always about, can you save fees, can you save costs, or make the money? And so that's our go-to-market approach, to embed this token standard and this account standard that we call ZK compression into all the wallets, all the apps that currently are on Solana. And so then what happens when we reach that point where we have where the standard is being meaningfully adopted, and we're seeing early adopters do this right now, but there's obviously a long way to go. Once we're there, now we have all of a sudden ZK native state, which is Poseidon hash, so it's very ZK friendly. And it's very trivial at that point to extend the state transition function that we currently prove in the circuit to create a ZK proof with, for instance, private inputs, right? So at that long-term game, you can build that vision of having this encrypted state at rest. So that's how we think about this all.
Okay, so longer term, you want to go back full circle to the privacy element again. And I agree. It's kind of wild the way on-chain works now, where every bank account, everybody can see every transaction coming in and out. I think in maybe some 10 years, we'll look back and think about how crazy this was. Yannik, posing the same question to you. Let's talk about ZK Endgame. What are your thoughts? When are we going to get there? What's it going to look like?
Yeah, so I think one of the big realizations that I think the space in general and especially people in cryptography and privacy have made over the last few years with so many ZK projects and so many ZK L1s and L2s proposing privacy and private computing is that people, users, investors, basically all players involved have been disillusioned by this technology, by actually not providing this kind of privacy that people, institutionals, and users need at the end of the day. And that's why, in general, we've shifted towards calling this kind of approach to privacy 1.0, whereas computing over private shared state privacy 2.0. I think adoption-wise, that's quite significant because things like dark pools, which nowadays makes up of around 60% of daily US spot trading volume, happens within dark pools, so private trading venues, right, where all of the institutional traders involved have a level of privacy-preserving trading because they don't want to expose their trading strategies to all players trading within those exchanges, right? And so if we want these kinds of trading venues on chain, we cannot just have encrypted peer-to-peer payments where I generate a zero-knowledge proof and can send something to you, and you can generate a zero-knowledge proof and send something to me. These kinds of interactions are way too limited. What we actually need is applications that can have encrypted computing, and what we also need is we need better user experience, both for the user but also for the developers. So within zero-knowledge proofs, the kind of programming framework that developers had to familiarize themselves with in the past had really been a relatively mathematical, almost PhD level understanding of how this cryptography works, and then people had to write arithmetic circuits. In my opinion, no developer should even have to know the term arithmetic circuit or circuit. Instead, they should just write computer programs, and those computer programs, just like normal smart contract execution, should be executed in private. And I think that's an entirely different model that we are operating in, and it becomes way more powerful. And we've seen that not just in financial applications, but applications in general. So we, for example, are working with some Web2 customers, mainly because last year we acquired our largest Web2 competitor who've been doing encrypted computing for defense, healthcare, and AI. That with encrypted shared state, everyone can just have their data and we can collectively compute some function without each individual user having to keep the secret to themselves and generating a zero-knowledge proof. So the kind of architectures that we can construct with that are more beautiful. There is ZK requirements in all architectures, and I think that's an important aspect. So some parts of all of these architectures should use ZK. I think at the end of the day, it also doesn't matter what specific technology is used under the hood. I think in general, what matters is what kind of applications can be enabled. And what I've seen so far is that there hasn't been any substantial widely adopted ZK applications so far. If we look at privacy-preserving applications, the biggest things that we have are Monero and Zcash. Zcash isn't really adopted if you compare it to Monero, and so these kinds of applications don't really scream, this is the technology of the future. This kind of programming and architectural paradigm is the future. So that's why we see this shift from privacy 1.0 to privacy 2.0, where it's actual computational applications that can be built that are basically just smart contract executions, but encrypted now. And so the way we do that with Arjoon is we are currently live on Solana DevNet with our testnet. And so for developers, all they need to specify within their smart contracts on Solana essentially is what kind of functions should be executed in private, what state should be encrypted, and then it's very smart contract native execution that those developers can utilize in a fully privacy preserving way. And that then allows for things like fully encrypted trading. So in general, I would say ZK is part of the privacy evolution, and I think an important part of cryptography. But at the end of the day, I think we won't see these kinds of ZK-centric architectures, but ZK will play an important but I guess more foundational role within those architectures.
Thanks, Yannik. You mentioned, Zcash, Monero, they're not really that popular. No real ZK privacy application is really that popular. You mentioned developers shouldn't have to know about circuits or any of the math to do with it. So, forget about the end game for a moment. Let's talk about right now. What are the biggest barriers to ZK adoption? Is it the math? Is it the talent pool? Is it the lack of caring about privacy by users? What is the multiple faceted approach you're seeing here to get ZK to that level? What's holding it back right now? Is it standards? Delve into this, please. We'll start with you, Yannik.
Yeah, so I think over the last few years, I think that has changed a bit, but especially within Ethereum over the last few years, a lot of the ZK talks were quite technical, talking about, we have this new ZK protocol that makes things slightly faster, stuff like that. But I think none of these discussions sort of were groundbreaking. None of these sort of discussions were some new 0 to 1 breakthrough like ZK itself has been. I think if you want to see more ZK adoption, I think one important aspect has always been developer experience. I think Aztec, for example, has done some good work in that regard. But still, at the end of the day, I'm not super bullish on requiring any developer to explicitly think about ZK and building applications for ZK. I think at the end of the day, that's an approach that never brings this kind of adoption that we need. Maybe we actually never need the broad majority of developers to build explicit verifiability into the applications. Maybe it's just the underlying tech stack that should provide those things. So I think in general, abstracting away these kinds of cryptographic primitives is important for adoption. What we've done with our encrypted computing at Arjoon is we've, for example, built a Rust compiler that supports the Rust core library. So developers just write normal Rust code for their Rust smart contracts, and they don't have to worry about any of the underlying cryptographic operations. So I think that's the approach I would take in general, abstracting away this technology, and that at the end of the day will lead to more adoption.
Thanks, Yannik. Sven, what's holding us back?
Yeah, good question. In my opinion, it's mostly founders. The bottleneck is founders who solve real problems, and then hopefully ZK will be technology that can help them fix specific problems. But I think that's the way of thinking here. I think one good example of where ZK itself is not a magic bullet and doesn't justify existing of technology if it is. You see some optimistic rollups and ZK rollups, and you can clearly see that it seems like what users care about is not necessarily, hey, this rollup is ZK powered. Even though obviously on a technological level and trust assumptions, etc., it's much better than competition. So you really have to have a founder who, or a group of founders, because founding something is hard. A group of founders who really care about solving a problem that users care about, and I think, and then ZK, in my opinion, should just power it under the hood wherever it is feasible, right? So one thing I talked about is payments, which is just slowly payments and cold storage for funds, which is just slowly picking up. But if you I think it's not been adopted so far, but it's one of these technological shifts that just takes longer. So I think when people ask about why hasn't ZK had its breakthrough yet in terms of powering a lot of users and making lives better, it's really just a question of deferring time horizons, right? You got to zoom out sometimes, and you got to see that for private cold storage, for instance, it's a super good use case, and then for cost reduction, and proving with succinctness, it's also super useful. And so so I'm very optimistic about getting there. And I think right now, and one big element is also usability. And I would argue that on the tech side, for specific use cases, we're already okay. Like the tech is good enough. We already fast enough proofs. I'll give you one example. We have apps using ZK compression to scale their user base, their tokens, their accounts. Apps like Farcaster, consumer apps like Tribe.run, Doodles, and they use it. They don't have to understand how ZK works. So I think it's relatively trivial to abstract that meaningfully. But what they do care about is like, how do I reduce the cost of my users, right? I need to get better unit economics. I need to scale to more users, etc. So, and then at that point, it's really like, oh, there's tech that happens to use ZK. That's totally fine by me because it gets the job done. And so that's how we think about it. It's like you just gotta have more founders who try to solve problems, and they're like, okay, let me use ZK for this. Yeah.
Okay, great, thanks. We're coming up on time, and so I'm gonna do some lightning round questions. So we'll be quick with this. What's your favorite failed ZK project, and what did it teach us? So just quick answers. If something doesn't come to your mind because you have no favorite projects, that's fine. Yannik?
I guess most of them. And I mean, what it teaches me really is that, solely focusing on one technology, right? Explicitly. I think it's really about expectations over promising things. So yeah.
Okay, Yannik. Swen?
I would say, so I think the consensus is that Zcash has not yet succeeded,
right.
Even though it's the original ZK project on chain. And I think it's definitely one of my favorites because I think the model of how it views the vault makes sense. It's just logical.
Yeah.
And I think that it's just the timing question, so the market will catch up with it. Yeah.
Okay, quick. And last one, because we're over time. Just one word answer. What's ZK more important for? Scalability or privacy? Sven? So,
what is it more important for?
Yeah.
Well, I think privacy is fundamentally important for society, for humanity even, and proof of humanhood. So ZK identity proofs, and then also the private money. I think that's just super important, but it's like one of these problems where you need to fix the incentives underlying, like solving vault hunger. It's like theoretically possible, but like the incentives are just, it's so complex, so hard to solve that you just can't go straight on with a go-to-market. You have to have a go-to-market that works. And so I think going with scalability for the go-to-market to then eventually also solve privacy, I think is a very good approach and might work.
Okay, cheeky answer. Yannik, tended scalability or privacy?
I think in general, what ZK is about is computational and informational asymmetry, right? And I think every system that uses ZK for privacy, even when you use ZK for scalability, because some information is only accessible and only stored in some location and not in another location, right? So if you think about it that way, then I think everything at the end of the day is privacy, because there's different levels where information and computation should occur and exist.
Okay, great. Thank you, Sven, Yannik. Thank you for your time. Everybody, can we give it up for our panelists?